A very good morning to everyone. Welcome in the class. Let's crack CSIR UGC NET together. Unacademy is one of the India's largest platform for the preparation of CSIR UGC NET. And I'm your educator Farida Bandukwala. I have a teaching experience of 10 years. I've qualified MP-SLET examination in year 2018. If you're opting for Unacademy, what all things you are going to get? You're going to get daily live classes so that you can be into that momentum of studying every day. And in live classes, you can ask your doubts and queries directly at that point of time. The whole syllabus is quite structured so that you can complete all the 13 units in a small span of time. The live tests and quizzes are taken so that you can evaluate yourself that how much you have learned so far, or whatever you have learned, how much you can actually utilize that in solving the questions. Then you will have unlimited access towards all the videos and all the things which has been recorded in that particular category. Unacademy tries to give as many free live classes as it can. So these free live classes are conducted on YouTube. So the classes which are conducted on YouTube are completely free of cost. Just you need to subscribe the channel and you'll be getting the notifications of all the upcoming classes. So in our case, the name of the channel is Let's Crack CSIR UGC NET. Then there are special classes. For attending the special classes, what you need to do is you need to download the Unacademy learning app. After downloading the app, make your account. After making your account, you'll be asked to fill the referral code of an educator. So fill my referral code FB01. By using my referral code, you will be able to attend my special classes completely free, and special classes of other educators that too completely free. So do not forget to use my referral code, that is FP01. After that, there is this plus subscription. This plus subscription is a completely paid subscription, and in this plus subscription, all the 13 units are described in a well-defined manner, and these 13 units will be covered in a very specific manner so that you do not miss the specific important topics. So all the 13 units are done in that manner in the plus subscription, and the amount that you need to pay for 12 months is 11,550 rupees. For 24 months, you need to pay 16,800 rupees. And recently, by using my referral code, you will be getting an additional 10% discount. So my referral code is FB01. Do not forget to use my referral code, that is FB01. So this was a little about Unacademy. Let us talk about the topic of today, that is chi-square test. Chi-square test. So the chi-square test is a biostatistical test. Then we'll be talking about its definition in various points. So first of all, it's a test of significance. The test of significance. That if a study which you are doing is significantly making any kind of difference or not. That is, it's a test of significance. It was first time given by a scientist known as Carl Pearson, and he gave chi-square test in year 1990. So chi-square test is a very useful measure for comparing the experimentally obtained result with those of theoretical, which is based on whatever hypothesis we have made. So it's a measure for comparing, it's a measure of comparing, the measure of comparing experimentally obtained result with those expected theoretically, for which we have formed the hypothesis. Based on hypothesis. And this chi-square test is denoted by a symbol like this. So there's a formula for chi-square test. First of all, let us know that It's a test of significance given by Carl Pearson. Then it is a measure of comparing. Most important thing which you should not forget in this page is it's a measure of comparing. Measure of comparing experimentally obtained result with those of which were performed theoretically, and it is given by a symbol chi-square. Right? So the formula which is used for chi-square test is like this. Chi-square is equal to summation of observed minus expected upon expected. So observed minus expected. So observed, we should observed minus expected whole square upon expected. This is the formula for chi-square test. Now talking about this formula, so it's a mathematical expression. As we can see that it is something related to mathematics, because we can see the symbol summation, then some square is there, and also it's a mathematical expression representing the ratio between experimentally obtained result and theoretically expected result, which is based on the hypothesis. It uses the data in the form of frequency. Most importantly, uses data in form of frequencies. So if we are saying in the form of frequency, what are we trying to say? That is the number of occurrence of an event. That is number of occurrence of an event. Right? So it uses data in the form of frequency. Then it's a ratio. It's a ratio between experimentally obtained result and theoretically obtained result. This is what chi-square test is. We have seen the formula, we have seen the theory. Now let us move further. So chi-square test, it is calculated by dividing the square. Let us just see, dividing the square of overall deviation in the observed and expected frequency by the expected frequency. See, what I'm trying to say is it is calculated, this chi-square is calculated by dividing the square of overall deviation, that is the summation. So overall deviation in observed and expected frequency. Whole thing divided by expected frequency. Whole thing divided by expected frequency. This is what chi-square has to say in words. Otherwise, if we are saying looking at the formula, it would look like this: summation observed minus expected whole square divided by expected. So what is O? O is the frequency observed. O is frequency observed. E is frequency expected. And summation is sum of, that is the total thing. So it is usually done in the form of frequencies. Whenever there is a data which is expressed in the form of frequency, that is the number of occurrence of events, then only the chi-square will be applicable. Right? Now, before moving with the whole thing and talking about some of the example of this thing, we need to know certain other things as well, which is quite important while performing chi-square test. So let us talk about that. If there is no difference between observed and actual frequency, and observed frequency, the value of chi-square is 0. The value of chi-square is 0. Remember, it can be asked that what is the validity of this statement. So this is a statement that if there is no difference, the whole chi-square is going to be 0. If there is difference between observed and expected frequency, the value of chi-square would be more than 0. If there is difference, between observed and expected frequency, chi-square, the value of chi-square is going to be more than 0, right? But the difference in the observed frequency may also be due to sampling fluctuation, and it should be ignored in drawing the inferences. So how these things, but the differences which are observed in the observed frequency because of the sampling and all, these all things need to be corrected. So there comes another thing, that is degree of freedom. So I'm explaining all of these things in a very, very simple manner according to bio point of view, without going more into mathematical and technical thing. We are dealing it in a very simple way. We are moving ahead. So degree of freedom comes over there. So why degree of freedom came into being? We need to see this. Whenever difference in observed frequencies, whenever difference in observed frequencies is due to sampling fluctuations, it should be ignored. It should be ignored. Drawing inferences. It should be completely ignored in drawing the inferences. Okay. Now talking about degree of freedom. So in chi-square test, while comparing the calculated value uh, of with the table value, we have to calculate the degree of freedom. Whenever we are getting a calculated value and we have a table value, we have to compare. So in that case, the thing comes, that is degree of freedom. So degree of freedom is calculated from where? The another thing. So first of all, we'll see that degree of freedom, and then how it is calculated, the another important thing. So in test, while comparing the calculated value with the table value, we need degree of freedom. We need degree of freedom, right? Now how is it calculated? So degree of freedom is calculated from the number of classes. Degree of freedom is calculated from the number of classes. Therefore, the number of degree of freedom in a test is equal to number of classes minus 1. We'll be doing a calculation for this as well. I'm just going to tell you. So just remember this sentence, and I'll be explaining you how to calculate it actually. So what I'm saying is that number of degree of freedom in a test is equal to the number of classes minus 1. Right? Now how to explain you this thing? We are just going to see that how it is done. Remember these two things for degree of freedom. Okay. So if there are 2 classes, 3 classes, 4 classes, the degree of freedom would be 2 minus 1, 3 minus 1, 4 minus 1 respectively. If there are 2 classes, so the degree of freedom will be 2 minus 1, 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 2 minus 1. If there are 3 classes, the degree of freedom is going to be 3 minus 1. For 4 classes, the degree of freedom is going to be 4 minus 1, right? So in a contingency table, the degree of freedom is calculated in a different manner. This is for the simple calculation. But for contingency table, let us write on another page for calculating degree of freedom in a contingency table. In a contingency table. So how it will be calculated? The degree of freedom is equal to r minus 1 whole thing into bracket into c minus 1 whole thing into bracket, right? So this degree of freedom here we have written as d dot f. So what is r and what is c? This is your curiosity that I have written r. So what is r? R is the number of rows in a table. Number of rows in a table. And what is C? C is the number of column in the table. C is number of column in a table. Okay. So R we have seen, C we have seen. So thus 2 into 2 contingency table. For that the degree of freedom is going to be 2 minus 1 into 2 minus 1, that is equal to 1. So thus in a 2 into 2 contingency table, the degree of freedom is equal to 2 minus 1 into 2 minus 1 is equal to 1. My mom is again there in the class. Good morning, Mama. Thank you for joining the class. So this will be the value. Now in a 3 into 3 contingency table, it is 3 minus 1 into 3 minus 1. So 3 minus 1 into 3 minus 1 is going to be 4. Here I think I haven't, yeah, here also we have written this. So whenever the contingency table will be 3 into 4 contingency table, it is going to be 3 minus 1 into 4 minus 1, that is equal to 6, and so on. So this is how we calculate the value of degree of freedom. Now we are saying contingency table. So let us talk about that also. So another thing that I am going to explain you is contingency table. Contingency table. So the term contingency table was first time given by Carl Pearson. Term given by Carl Pearson. So what is a contingency table? So contingency table is a type of table in a matrix format that displays the multivariant frequency distributions of the variables, and that are heavily used in research, business intelligence, engineering, and scientific research. And they provide a basic picture of the interrelation between two variables and can help find interactions between them. So that is what a contingency table is. It's a type of table in a matrix. Type of table in a matrix format, and it displays the multivariate frequency distribution of displays the frequency distribution of variables. And what is its use? That we have seen, it is used in research, it is used in business intelligence, scientific research, etc. So what does they provide? They provide a basic picture of the interrelation between two variables. And when the interrelation between two variables will be found out, it will help find the interaction between them. So provides basic idea of interrelation between two variables. And can help find interrelation between them. Interrelation between them. So this point is the most important point that provides basic idea of interrelation between two variables. Interrelation between two variables and how they are going to interact with each other, those all things will be understood with contingency table. So here it's not interrelation, it should be interactions between them. This is what contingency tables tells. So the value depends on the number of classes, or in other words, it depends on the number of degree of freedom, and the critical value of probability. It depends on these two things. So contingency table, the value depends on number of classes or degree of freedom, and another thing on which it depends is critical value of probability. Critical value of probability. Right? So 2 into 2 table where there are only two samples, each divided into two classes, and a 2 into 2 contingency table is prepared. It is also called as four-fold or four-cell table. So when 2 into 2 table, when there are two samples and each sample is divided into two classes. So we get a 2 into 2 contingency table, and this type of table is called as four-fold table, four-fold or four-cell table. This is what the table will be known as. So let us draw a 2-row and 2-column table. Let us see how it will look like. 2 rows into 2 columns. How does it going to look like? So column 1, column 2, here row 1 and row 2, and here we write column total, and here we will write row total. Sorry for a very rough table, ignore it as well. So if there is a value, the row total is going to be 1. There is a value, there is a positive value, the row total is 2, and for this CT 1 and column total 2. So for this, what will be the degree of freedom? So degree of freedom would be R minus 1, C minus 1, and this is going to result into 2 minus 1, here 2 minus 1. So total answer would be 1 into 1, that is 1. So this is how the degree of freedom is calculated. Those who are attending the class live, they can write in the chat box whether they have understood this thing or not. It will be a great help so that I would understand that you people have understood. Now before moving with the characteristic, application and assumptions of chi-square test and how to determine the chi-square test, I think it will be very interesting if we take up a numerical. So before applications, we would just say see the assumptions and determination. Assumptions and determination, then our one of the question, and then we'll be moving towards another thing. So what are the assumptions? Assumptions for validity. Assumptions for validity of chi-square test. So there are few assumptions. Let us talk about those assumptions. First is all the observations must be independent. All observations must be independent. So no individual item should be included twice or the number of items in the sample. All the observations must be independent. There should be no repetition. Okay. Then the total number of observations should be large. Total number of observations should be large. Okay, should be large, and it should not be used if n is greater than 50. Two things, should not be large and should not be greater than 50. All events must be mutually exclusive. All events must be mutually exclusive. So for comparison purposes, the data must be in original units. Data must be in original units. If theoretical frequency is less than 5, then we pool it with the preceding or succeeding frequency so that the resulting sum is greater than 5. So this is the most important thing, because rest all of the things are okay. If theoretical frequency is less than 5, if theoretical frequency is less than 5, then we pool it with preceding or succeeding frequency. We pool it with preceding or succeeding frequency so that the resulting sum is greater than 5. These are the assumptions of chi-square test. I hope you have understood the assumptions. After assumptions, let us move towards how to determine the chi-square test. What happened? Yeah. So determination of chi-square test. So following things will be done. First of all, there should be identification of problems. Identification of problem. Identification of problem. First thing. Second, make a contingency table and note the observed frequency in each class of the event, row wise, that is horizontally, and then numbers in each group of the other event column wise, that is vertically. So make a contingency table. Make a contingency table for calculating the degree of freedom. Then set up null hypothesis. Set up null hypothesis. So null hypothesis is given by H0. So according to null hypothesis, no association exists between the attributes. This needs setting up of alternative hypothesis. It assumes that the association exists between the attributes. So setting up null hypothesis and alternative hypothesis. That is HA. Now calculate the expected frequencies. calculate expected frequencies. So expected frequency would be denoted by E. Now find the difference between expected frequency and observed frequency. O minus E is calculated. Then finally calculate the chi-square by the formula that we have seen. So calculate chi-square by formula. The value is going to range from 0 to infinite. Value should be between 0 to infinite. This will be the value. So now we have seen how to determine a chi-square. Now we will be seeing an example. Okay, first of all, let us take a little time to write down the question. So the question is two varieties of Snapdragon. Two varieties of Snapdragon. One with red flower, one with red flower, and other with white flower were crossed. So the result obtained in the F2 generation, the result obtained in F2 generation is like this, that is 22 red, 52 pink and 23 white flowers. Now it is desired to ascertain these figures show that the segregation occurs in the simple Mendelian ratio of 1:2:1. Now it is desired, the language is going to be like this: desired to ascertain these figures show that segregation occurs in Mendelian ratio of 1:2:1. 1:2:1. This is the question. Now let us talk about the solution. Talking about the solution. The first thing, we will set up the null hypothesis. Null hypothesis is H0. So what does this says? That the genes carrying the red color and white color characteristics are segregating in simple Mendelian ratio. So we have to write this statement: the genes carrying red color and white color characters are segregating in simple Mendelian ratio that is 1:2:1. So what will be the expected frequency? This we have to calculate. So red is equal to 1/4. So we'll just calculate the total number. So that is 22 red, then 52 pink and 23 white. So what is the total number of flowers obtained? That is 97. So for red, 1/4 into 97. This is the expected. The red would be obtained in 1/4. So that is 24.25. Then for pink, it should be 2 by 4. And why we are writing 4? Because we are saying 1 is to 2 is to 1. So total it becomes 4. So here we are writing 4. Okay. So 2 by 4 into 97, that is going to be 48.50. Now for white it is 1 by 4 into 97. So that is again 24.25. So these are the expected frequencies. The expected frequency should be like this. Let us just see. See, we are saying it should be in the ratio of 1 is to 2 is to 1. That is for this red, pink and white. Pink is the hybrid, so that should be the highest. So total 4. So 1/4 of the total number of flowers obtained should be red. For pink it should be this much number and white should be in this much number. Now we have to see. Now we have to draw the table. Before that I will take 2-3 slides. Just give me a second. We'll add the slides and we'll continue. Just a second. So yes, I have added the slides. Now we'll draw the table. That was our next, that drawing the table. So observed frequency, expected frequency and deviation. And here in this we'll write red, pink, white and total. Okay. So observed frequency for red, how many red flowers we have obtained? 22. How many pink flower experimentally we have got? 52. How many white flowers we have got experimentally? 23. So total number of flowers are 97. Expected frequency, that also we have calculated. Red should be 24.25. Pink should be 48.50. White should be 24.25 and total should be 97, right? So what is the deviation for red? It is minus 2.25. For red it is 3.50. For white it is minus 1.25. So now we have to calculate the chi-square. So chi-square is summation of observed minus expected frequency whole square upon expected, right? So we'll just put the things observed. So minus 2.25 whole square divided by 24.25 plus 3.50 whole square divided by 48.50 plus minus 1.25 whole square upon 24.25. So I am giving you just a small span of time to calculate this. I'll be also doing it. So I'll be just using the calculator for doing this. So I'm using the calculator. So for this, it is 5.06 upon 24.25 plus 12.25 divided by 48.50 plus 1.56 divided by 24.25. So after that it is 0.21 plus 0.25 plus 0.06. So like this the answer is 0.53. So what is the conclusion by solving all this? What is the conclusion? We got the value between 0 to infinite. So the calculated chi-square value, that is 0.53, is less than the tabulated chi-square value when it was calculated. So when we have seen the calculated tabular value of chi-square, it was 5.99 at 5% level of probability for 2 degree of freedom. So the hypothesis is therefore in this agreement. So the hypothesis therefore is in agreement with the recorded facts. So conclusion is the calculated value of chi-square, that is 0.53, is less than the tabulated value. So the agreement is in the statement is in agreement with the recorded facts. Statement is in agreement with the recorded facts. So this is how we calculate the chi-square test, how we determine the chi-square test. Now let us see, to sum up the whole thing, we'll just see the characteristics of chi-square tests. Characteristics of chi-square tests. So first characteristic, this test is based on frequency, where in the total distribution the test is based, where in the theoretical distribution the test is based on mean and standard deviation. Here the chi-square test is based on frequency. The other distributions can be used for testing the significance of difference between the single expected value and observed proportion, but this test can be used for testing the difference between the entire set of the expected and observed frequency. Testing the difference between entire set of expected and observed frequencies. After that, the new chi-square distribution is formed for every increase in the number of degree of freedom. A new chi-square distribution is formed for every increase in number of degree of freedom. Then this test is applied for testing the hypothesis, but not useful for estimation. Applied for testing the hypothesis. Testing hypothesis. Right? Now, applications of chi-square test. In a very quick manner, we'll do the applications. So, chi-square test is applied to varied problems in agriculture and medical sciences. So, varied problems of agriculture, biological, and medical science. Now, for what it is done? To test goodness of fit, to test the goodness of fit, to test the independence of attributes, to test the independence of attributes, to test the homogeneity of independent estimates of the population, to test the homogeneity of independent estimates of the population variance. Then it is used to test the detection of linkage. To test the detection of linkage. to test the detection of linkage. So like this, we have completed the chi-square test in a whole light of everything. We have completed the thing, and hope you people have understood. Oh, just a second. Just a second. So this is it for the class of chi-square test. We have completed in like all the things that we should have covered. We have done it. And as we say in the starting and in the end, let's crack CSIR UGC NET, and that is the name of our channel as well. That is Let's Crack CSIR UGC NET. If you haven't subscribed to our channel till now, subscribe the channel, hit the bell icon for getting all the notifications of the upcoming classes. Please like my video if it really made you understand something or you like the presentation. And lastly, use my referral code FB01 for getting a 10% discount in the Plus subscription. Plus subscription can be really beneficial for you to qualify the examination. And use my referral code FB01 to attend the special classes on the Unacademy learning app as well. So do not forget to use my referral code FB01 for getting the special classes. Lastly, thank you for everyone for your patient listening. It was great teaching you all. Hope that you have understood the thing. We'll be meeting in the evening with another topic of GATE syllabus, and I'm extremely sorry for the disturbance in the background. And we'll be meeting in the evening, and we'll be doing a topic from the GATE syllabus. And tomorrow 10:30 we'll be meeting again, and we'll be discussing a topic of CSIR. Every morning 10:30 and every evening 5 o'clock I come and I teach. In morning CSIR, I teach GATE in the evening. So this is it for now. We'll be meeting in the evening. So it's a bye from my side. Hope you people